Right, hello Year 10s. So this is Thursday's lesson. I've got a couple of examples here to get you going. So yesterday's lesson flows on nicely with today's lesson. We're just looking at different types of looking parabolas or quadratic equations. So yesterday we looked at examples that look like this, and they take on that form of, and this is the standard form which we call the turning point looking formula or equation. So we call it the turning point. So y equals ax minus h squared plus k. And the numbers in those positions each reveal certain information. And the information that's revealed is detailed on page 518. This is a really important page for you to know. And this one right here is especially important, all right? The turning point form of a quadratic. It's just the form, the special form that it looks like. Okay, it's a bit different to y equals ax squared plus bx plus c, which is the one that we've been factorizing, factors of a and c to add to b. We're doing that, we're looking at that later on, but just right now, we're looking at this particular form here. So when it's written like that, it easily reveals the turning point, because the turning point is just that number there. That's the x coordinate. You can see it's in the x position of a coordinate, and whatever number is on the end is going to be the y coordinate. So if there's nothing on the end here, the y coordinate is going to be 0, because that's plus 0 on the end, because there's nothing there. Okay, and then the axis of symmetry is just going to be that number, because that's the x coordinate of the turning point. All right, so these are coordinates of the turning point. All right, so if the turning point has a number of 2 here and 3 here, it means on a Cartesian plane that the axis of symmetry is at 2 and the turning point is at 2, 3. So 1, 2, 3. Right there is 2, 3. All right? And the axis of symmetry goes down 2. So that number there is the axis of symmetry, but also coincides with the turning point. Now, let's take a look at the questions that we've got today, which don't necessarily look like that. They take the regular form of y equals ax squared plus bx plus c. Hopefully you can see that this doesn't. This was just an example from last lesson. All right. It's not that easy to graph these particular functions as it is this one. There are advantages and disadvantages to both, but for now, we're going to be looking at factorizing these particular quadratics, okay? And the way that we do that is by factorizing to find the x-intercepts. From there, we'll find the turning point, we'll find the y-intercept, and with that information, we'll have enough to actually graph it, to put it on a Cartesian plane. And I'll take you through both of these examples. Depending on how long this is going to take, I might put it into another video, the second question, but we'll see how we go. All right, so the first step, we'll do A first, is to factorize. So I'll just write that, factorize. That's step 1. So just like normal, factors of AC that add to B, and I'll just go ahead and replace AC and B with the numbers that are represented in the question. So notice that with this particular quadratic, there is no C. So our C value is 0. So factors of A, which in this particular case is 1, and C, which is 0. Factors of 1 times 0, that's 0. So factors of 0, as soon as there's a 0 on the end, your AC is always going to be 0. So factors of 0 that add to -2. All right, let's think of them. factors of 0 that add to -2. Well, I'm going to try -2 and 0. So -2 times 0 does equal 0. Cool. So -2 and 0 are factors of 0. But do they add together to make -2? They do, because -2 plus 0 is -2. So now I know that my factors are -2 and 0. And we set them equal to 0 because that's where you find the x-intercepts. So looking at each factor one at a time, what must x be to make this factor 0? Well, it must be 2, because 2 times 2 take away 2 rather, gives us 0. So x equals 2, or x equals, and the last one here, it must be 0. So x equals 2 or x equals 0. And they are our x-intercepts. So far, so good. So on our graph, when we draw this, the line of x squared minus 2x will go through 2 and 0 on the x-axis. Having known that now, and if I can just draw like a rough little graph, I will delete it, but if we know that our line passes through 2 and 0, you ready? There's 0, there's 2, so that's 1, that's 2, that's 0. What we're now going to try and do is work out the turning point. All right, we first work out the axis of symmetry. The axis of symmetry helps us work out the x position of the turning point. Because if you just split it in half, this line, you can figure out where the turning point is, because the axis of symmetry always goes through the turning point. So the way you do that is you grab your two coordinates, your two x-intercepts, which you figured out here and here, and you add them together and divide by 2, and that gives you the position in the middle. And that gives you the x-coordinate of the turning point, which is also known as the axis of symmetry. So I'll keep that over here for now, for your reference. But the way we're going to write this is the x-coordinate of the turning point, I'll just write TP, and then you'll just write 0 plus 2, which are the two numbers that you found to be x-intercepts, and you divide them by 2. And that gets you in between, in the middle on that x-axis. All right? So let's see. 0 plus 2 is 2. 2 divided by 2 is 1. And you can tell that on the graph. Look, it's the axis of symmetry, or the x-coordinate of the turning point, is at the position 1. And we did that mathematically. But you can see on the graph it makes sense. Okay? So now that we know the x-coordinate of the turning point, right, it's at 1, we can actually go ahead and put that number back into our function here, right? And where are we going to put it? We're going to put it into everywhere we see an x. And that'll tell us what y is, what's the y coordinate when x is 1. So let's do that. When x equals 1, y equals, and we're going to write this, but we're going to replace every x with a 1, because that's what we said, when x is 1. So let's do it. I'll put all my 1s in brackets to show I'm substituting. So instead of writing x squared, you write 1 squared. Take away 2 times 1. And what does y equal in this particular case? Well, 1 squared is 1. 2 times 1 is 2. So 1 take away 2 is -1. So therefore, your turning point is going to be your x-coordinate, which is 1, and your y-coordinate, which is -1. So 1, -1. That's your turning point. All right, so let's think of the steps that we took so far. So step 1, we factorized, and then step 2 is we find the turning point. All right, and we do that by first adding our two x-intercepts together and then dividing by 2 to get the x-coordinate of the turning point, which we also call the axis of symmetry. And then we sub that number back into the original equation where every x we find is, to get the y coordinate of the turning point. And then we write it like that. So now we have the turning point, we have the x-intercept. The last thing we're going to do is find the y-intercept. Now, in this particular example, I already know the y-intercept is 0, and it's because we have an x-intercept of 0, right? If you have an x-intercept of 0, it means that the line passes through right there, and that's also where the y-intercept is. For example, if that was x equals 1, the line would go through like that, and then you wouldn't exactly know where it's passing through the y-intercept. But in this special case, I know the y-intercept is 0. But to show you, I'm going to do it anyway. So for step 3, we find the y-intercept always when x equals 0. So what we'll do is we'll just put 0 into x, into our original equation. So here we go, let's do it. Y equals, now instead of writing x squared minus 2x, you write 0 squared minus 2 times 0 instead of x squared minus 2x. Now let's figure that out. 0 squared is 0. 2 times 0 is 0. So 0 minus 0 is 0. As we discussed, it's definitely passing the y-intercept at 0. So now we have all the information that we need to graph it. We'll go ahead and graph it. All right, so I'll draw my axes. There and there. I don't have any x-intercepts that are in negative territory, so I don't need to draw a line that goes really far back. I will go down a little bit because I do have a turning point that goes down to -1. So I'll have a little bit of negative here, but it's mostly going to be here and here in the positive territory. All right, let's put some arrows on our axes, label them X and Y. Now put some numbers in. What numbers do I need? I really only need to go up to 2. So there's 1, there's 2. I'll go to 3. There's -1, 1, 2, 3. I'm happy with that. Okay. Let's start marking some things. I'm going to use pink for the graph. So turning point is at 1, -1. The x-axes, so the x-intercepts are at 0 and 2. And the y-intercept we already know is at 0 as well. So I don't need to draw another dot. It's already been drawn with the x-intercept. All right, I'm going to go ahead and mark the turning point, and I can just go ahead and draw it now. So let's try it. I'm going to use my auto shape to see if it can do it for me. Here we go. Fingers crossed I can get done the first go. Oh, that was a bit weird. All right, let's see if we can get something going here. I'm trying. There we go. All right. I'm mostly happy with that. So I'll go ahead and finish by drawing arrows to indicate this graph goes on forever. And there we have it. That's how we graph. So remember, step 1, factorize to find your x-intercepts. And then step 2, use those intercepts, add them together, divide by 2 to find out the x coordinate of the turning point, also known as the axis of symmetry. Put that number you found back into the equation to find out what the y coordinate is for the turning point. You get it, and then you got your x and y coordinates of your turning point. And then just sub 0 back into that same equation to get your y-intercept. Now in this particular case, it was 0, just like it was for the x-intercept, right? But sometimes it's not like that. And then graph it. All right, guys, I'll do the second question in a separate video. This has taken a while, so stay tuned for that one. All right, thanks, bye.